Hello and welcome to this instructional video on projectile motion. For those of you wondering what it is, well, it could be anything as long as it's flying through the air. Let's say that you have a cannon and you fire an elephant at some velocity at some angle. What's important to notice here is you already have some important variables at play. Your initial velocity, we'll call that v sub 0, and the angle at which you fired it, we'll call that theta. As the problem progresses, your elephant flies through the air but eventually crashes back to the earth, causing major structural damage. You could be asked about any point on this graph until after it hits the ground. For the sake of this problem, we'll choose this point here. There's some important variables linked to this point. The time that it's spent between its initial position in this here, which is t, the velocity at that point, we'll call that v sub t, and its change in the horizontal and vertical, delta x and delta y, respectively. What's important to note here is that I have my delta y written from the ground to the point. That means that somewhere in this problem I was told that this cannon isn't actually above ground and is in fact below the ground, firing the elephant from the Earth's surface up into the air. Now for this problem we'll be solving for the velocity at the point in time, knowing the initial velocity, the angle it was fired at, and the time. The first thing you have to do is separate your initial velocity into its two component parts, horizontal and vertical, because in order to use kinematics, you have to be in one-dimensional motion. So, we'll separate it into its two parts, horizontal and vertical initial velocity. In order to do this, you multiply your initial velocity by the trigonometric functions, cosine and sine respectively. This forms a nice little triangle of velocities. Now, for this problem, solving for your velocity at the time, knowing this information, you only actually have to know the first kinematics equations. That's your velocity at the time is equal to your initial velocity plus your acceleration over your time. Now you have to solve for both x and y individually, so I'll do that. X is much easier, as you have no forces in either direction on the elephant in the x directions. So, your acceleration for x is 0. That means that your x velocity at the time is equal to your initial velocity of x plus 0 times your time. Now this, it goes away, and so your x velocity at the time is just equal to your initial x velocity. Your y velocity, on the other hand, is a little bit more difficult. That's because the elephant is being acted upon by gravity. That means it has an acceleration of -10 meters per second squared. That is, of course, if you have defined your world as up as positive. So, we'll put in our initial horizontal velocity, and we'll subtract 10 for your time. That's every second. Now that we have both of our x and y velocities at the time, we need to find our total velocity over the time. In order to do that, we're going to have to use the Pythagorean theorem. I knew it would come in handy one day. So, a squared plus b squared is equal to c squared. Simple, right? That means that your final velocity is equal to the square root of your initial x velocity, which is your initial velocity, times the cosine theta plus, and all of this is squared, plus your initial y velocity minus 10 times t. This is also squared. Now I haven't put any actual values in here, but this will work for any problem that you know these values. What's important to note is that it works for everything.